Let's talk a little bit more about Unity's physics system. Unity's physics system is comprised of two fundamental types of components on each of the objects. If I go and look at one of these random cubes that I have set up inside this simulation, which right now is just a bunch of falling cubes, they land on this floor and sort of stack with one another. The physics system is comprised of two main types of components. The first component is this one here, the box collider, right? Or actually the colliders in general. If I go to add component and I go and look at physics, and the 2D physics system has these same type of components as well. But if I go and look at physics, I can see there's a bunch of different types of colliders here. Now there's box colliders, capsule colliders, there are mesh colliders, sphere colliders, terrain colliders, and wheel colliders. Colliders denote the shape of objects in the physics system. So, as an example, let me go and take all of these cubes, and I'm going to disable the mesh renderer, right? These cubes are still there, and they still exist in Unity's physics simulation. Now, if we take a look at our game window, they're invisible. There's nothing we can see about them in the actual video game. But if we take a look at them in the scene view, then we can see that they're actually still there. They're in Unity's physics system. And if I go and hit play and watch this thing, I can see in my scene view that they're still being simulated in Unity's physics system, right? All of these objects have box colliders and rigid bodies, which means that they're being simulated to look like boxes in the shape of boxes, but they're not being rendered. If I toggle this mesh renderer on, there they are, right? If I toggle them off, they're gone. All right, in addition to the box colliders, we also have, if I go to 3D object and I go to sphere, by default, the sphere will have a sphere collider on it, right? So the sphere collider is essentially just, exactly what it looks like, a sphere, as opposed to a box, right? A box has that shape that looks like this, 6 sides. The sphere looks like this. The other types of colliders that we might have are mesh colliders, which are the shape of the mesh attached to it. So if you have like a complex model that you get from an artist that looks like a doorway or a bridge or some other more complex shape other than just spheres and boxes, then you can essentially say, I want the shape of this in the physics system to be the shape of that mesh or the shape of that object. We have the sphere colliders, we have terrain colliders, which are used for the terrain system, which we'll probably be talking about in the future. Wheel colliders, which are used for wheels, which we may talk about in the future, although these aren't used terribly often. And then we also have capsule colliders, which look like this. If I change the height of this thing, we can see what it looks like a little bit better, right? Notice how this object now has two colliders on it, a sphere collider and a capsule collider. I'll disable the sphere collider so we can better see what the capsule collider looks like. It kind of looks like a pill, right? This is used a lot for characters in a lot of video games. We shape our characters to look like these capsules, these pill shapes, so that they're nice and smooth on the top as well as smooth on the bottom, so that they slide nicely along surfaces. And then we keep them sort of standing upright like this. All right. Colliders are one component or one set of components in Unity's physics system. The other important set of components in the physics system is this one, the rigid body. The rigid body determines whether or not this object is simulated by physics. So what do I mean by that? Well, right now, all of these cubes, they all have box colliders and they all have rigid bodies. If I go hit play, they're all going to fall and behave as if they're shaped like cubes, right? If I were to remove the rigid body, say I select these, the cubes here that are at the bottom, and I remove the rigid body component from them. I'm going to click on this triple dot thing over here and hit remove component, right? Now these no longer have the rigid body component. Watch what happens. Those boxes that are on the bottom will no longer be simulated by Unity's physics systems. Just the top boxes are. These ones are essentially just stagnant. They're just sitting there, in space. If I take those, I can probably see this a little bit better if I rotate this a little bit more so those other boxes probably bounce off them or don't stay on them, right? So those bottom boxes don't have rigid bodies on them, so they're not going to be simulated. They're not going to be updated based on Unity's physics simulation. Only the other ones are. Now, if my game's running and I suddenly go to these and I say, hey, I'm going to add a rigid body component, suddenly they all start falling, right? So colliders designate the shape of these objects. The rigid body designates whether or not these objects should actually be simulated by physics. Let's look at another interesting thing here. So these cubes right now all have box colliders on them. Let's go and select these again. Let's add rigid bodies to them. So when I run it like this, with all of them with box colliders and rigid bodies, they're all going to fall. They're all going to behave like boxes, right? If I select every single object that I have here, and I remove the box colliders, and instead I add sphere colliders, what do we think is going to happen here? Well, all of these objects are going to be simulated because they have rigid bodies, which means they're going to behave as if they're in the physics simulation. But the shape of these objects are going to behave as if they are spheres, even though they look like cubes. So they're rendering as if they look like cubes, but they're going to behave in the physics system as if they are spheres. Let's go and take a look at what that looks like. Okay, they're all just stacking on each other, right? Let's offset them slightly from one another so they don't stack perfectly, which is actually what's happening right now. Let's see, if we take these objects and do something like this, just so they're kind of offset from one another. There we go. And then we run this thing. See, notice how they all just roll, right? They're all just rolling right along. And it's because they're all behaving like spheres. They're all acting as if they're marbles, essentially. A couple other interesting things that we can do with all of our rigid bodies and with our colliders. There's a whole bunch of different settings in here. Mass, how heavy these things are, how dense they are, essentially. We have drag, which is how much these objects slow down over time, right? The natural forces that are slowing down their velocities. Angular drag, how much the rotation of these objects slow down over time. Whether or not they use gravity, right? If I turn this off, so they're not using gravity, these objects, well, they're not going to fall. I could probably grab one of these things and just sort of, can I like push the other ones? Yeah, so I can just sort of like push them around like this, and so they can start flying around without having gravity attached to them or anything, right? There's a couple other options in here, but one important one that I want to point out is this, the constraints. We can freeze or lock either their positions or their rotations. So if I lock their position on, say, the x-axis, right, as well as the z-axis, now when I hit play, the only axis that these will move on is the y-axis. So they're only going to move up and down. They won't be able to move essentially left or right. I need to actually have all these things simulate gravity so we can see what that looks like, right? And I actually need to check this on all the objects instead of just one of them, which it looks like I did. So let's go ahead and check it on all of the objects. I have them all multi-selected. I want them all to use gravity. We're going to hit play. Now these things should only be able to move up and down, right? See how they're all just kind of stuck, right? They all fell on top of each other, and they can't move left or right or anything. They can't move on the x-axis or on the z-axis at all. They can only move up and down. So they're just sort of stuck rolling on top of each other. So that's an overview of both the colliders as well as the rigid body components in the Unity game engine.